Okay, we have here today another integral from the MIT Integration Bee 2022, regular season number 15. We have the integral from 0 to 2 pi, 1 minus cosine x to the fifth times cosine 5x dx. Okay, this will be kind of an alternative method video. In another video, what I did is we did this one kind of expanding it out and trying to quickly identify that a lot of the individual integrals we get when we expand it out are going to be just 0. For this method, my starting point is going to be just this 1 minus cosine x. What we can recognize if we had sine squared x and we reduce this, what we're going to get is 1/2 1 minus cosine 2x. And so this part here is really similar to this. It's just the angle that's different. So what I can do is if I input on here x over 2 and do the same thing here, and at the same time, just to clear this 1/2, I can multiply by a 2 on both sides. So then what's going to happen on the left side, we have 2 sine squared x over 2 equal here to 1 minus, when you plug in x over 2, the 2's cancel and we just have 1 minus cosine x over here. So what we can do is going this way, I can take this piece here and we can just plug this back in here and see what we have. Then from here what we can do, let's just kind of simplify the powers. I can distribute the fifth power in on the 2. So then we have 2 to the fifth there and distribute it in here on the sine squared. So doing it that way, 2 to the fifth is 32. We can factor that out front as a constant. Then here, this is just going to become sine to the 10th, x over 2, all this stuff here. And then here, I think what's going to be nice is if I just do a u substitution, very simple to clean this up, but it's also going to fix the bound because then the bound's going to be going from 0 to pi. So I think it has two benefits. So I want to do u equal to x over 2. So then, of course, x is going to be 2u. Take a derivative, dx is just going to be 2 du. So go ahead with this. We got our 32 out front. Plug in 2 pi someplace here. No, here. Plug 2 pi in here, and then u is just going to be pi. Plug in 0, and we get 0. Then this one's going to be sine to the 10th. Now we have just u. Cosine 5x, you plug 2u in here, this becomes cosine 10u du. But actually, I forgot that 2 right there. Let's bring that out front as a constant. I can multiply times 32, and we can make this into 64 over here. And now one thing I failed to mention before is the idea for this came up in the comments from Sable8172. I did another video on a similar problem we had. And what came out of that is the other problem, which I did in another video, really similar to this, and I can use the method I used in that video, which is reciprocal beta functions. Okay, so we have our formula over here to the right, and we're perfectly set up where we've got sine and cosine. Here, the variable, the coefficient here is just 1, so this substitution fixed that for us, and it also fixed the bound, so we're going from 0 to pi. So matching up with this format here, they have the exponent here as x minus 1. So to do that, our x value in our problem is going to be 11 in order to get back to 10. And here the y value is going to be just 10. So what I can do is just go to the formula and plug in. So what's going to happen, we still have 64 in front. Pi, cosine 10 pi over 2 here, that's just going to be 5 pi. We can reduce it later. And then here, 2x minus 1. X minus 1, that's just going to be this 10. So we're going to have 2 to the 10, x, which is 11. And then we have the beta function here. Let's see, so x plus y plus 1 over 2 for this first piece, that's going to be 22 over 2, or 11. And then for the other part, x minus y plus 1 over 2, that's going to be x minus y is just 1 plus 1, 2 over 2, that's 1. So what we have here is just beta function of 11, 1. Now, just to make this clear, if you have this notation, like if you have beta function AB, this is going to be the same thing as gamma A, gamma B over gamma A plus B. So simplifying this, 64, let's write that now as 2 to the 6th times pi. We can simplify more later. Cosine 5 pi, odd coefficient, that's going to be a minus 1 right there. This is going to be over 2 to the 10 times 11. Now for the beta function, using this here, we're going to have gamma of 11 times gamma of 1 over, added up, gamma of 12. But now for the gamma function, gamma of 1 is the same thing as 0 factorial. That's just 1, so that goes away. I can actually flip this and put this into the numerator. So let's bring gamma of 12 up here. Now we can still get some more cancellation here. For gamma of 12, let me rewrite that. To reduce the gamma function for like gamma of n plus 1, we can say this is the same thing as n times gamma of n. So for gamma 12, we can write it as 11 times gamma 11. So now we'll simplify here. Let's rearrange things. We're going to have minus pi 2 to the 6th over 2 to the 10. I can write that as just 2 to the 4th here in the denominator. We got times 11, gamma 11. And now taking gamma 12, writing it this way, we can write this as 11 times gamma 11. Cancel 11 here, cancel gamma of 11 here and here. Putting it together for my final solution, we just get minus pi over 16, and that's it. Okay, so there you go. Interesting alternative with the reciprocal beta function. Thanks everyone for watching. Have a good day.